Okay, so we're going to be trying to solve this conduit fill type question here. So a few things I've highlighted. We're looking for the minimum size of dB2 conduit, so that's our conduit type. And then we're going to be using 600 volt non-jacketed conductors. Now we have a total here of, we got various different types, but we got number 3 RW90 XLPE stranded, 2 number 10 RW90 XLPE solid, 4 number 4 TW75 stranded, 9 number 6 TW75 stranded, and 1 number 6 bare conductor here. So we got a lot of information that we got to accumulate here. So first of all, total number of conductors, if we add them all up, it's going to be 19 different conductors. So if we just need to keep that in mind. Now for this question, we're going to have to be referencing 4 different tables. We're going to be looking at table 8 for the allowable percent fill of a conductor, table 10, more specifically A and C for solid and stranded. And then we're going to be looking at table D5 for our bare conductor here. So that's a bit of a different one, outlier. And then we're going to be looking at table 9G, which is going to give us the 40% of dB2 conduit. Okay, so let's start. If I take a look at my code here, let's start at table 8. So that maximum allowable percent ampacity of conduit fill. So I'm dealing with insulated conductors that are not lead sheathed. And I got many more than 4, I got 19, so I can fill that particular conduit up to 40%. So I'm going to keep that in the back of my mind here. I'll write that down, 40% fill. Now I got to come up with the amount of area that the conductors themselves are going to take up. So let's start with my number 3 RW90 XLPE stranded conductors. So for that, I'm going to be looking at table 10A. 10A is for stranded specifically. And then I've got R90 XLPE, that's my insulation type, 600 volt. And number 3 is going to give me an area of 61.99. So I'll write that down here, 61.99 millimeters squared, and I have 3 of them. Okay, next I've got 2 number 10 RW90 solid this time. So I'm going to have to go to table 10C, which deals with solid, and you'll notice that there's only 3 sizes here. So number 10 are 90 XLPE, and notice the asterisk here. The asterisk, that is going to be for unjacketed. So I'm going to be using that asterisk for all of them because we're dealing with unjacketed type conductors. All right, so that's got a cross-sectional area of 13.25. 13.25, and there's 2 of them. Next, I'll find my number 4 TW75. So the insulation is a little bit different here. I'm dealing with stranded again. So back to 10A, and TW75 is here. TW75, was it number 4? I think so. Hope so. That's 62.67. 62.67. Ooh. It was number 4. There's 4 of them. Let me just verify that. 67. Yeah. Okay. And then we got 9. Number 6 TW75. So that's going to be slightly smaller conductor. So cross-reference that. That's 46.73. 46.73. and there's 9 of them. Okay, and then lastly, I'm going to do the bear. So the bear, I got to go to table Appendix D, table 5. And here I got number 6 conductor, and I'm dealing with my standard flexibility, or standard stranding. And that, I gotta pay attention to this here, the occupied area that's going to take. So that's 17.5 millimeters squared. And there is only one. Okay. So now I gotta quickly do my math here. So bear with me as I do that. It is 61.99 times 3. It's 185.97. 26.5. 62.67 times 4. It's 250.68. 46.73 times 9 is 420.57. 17.5 times 1. Should have been able to do that in my head. 17.5. And now I got to add them all up. 420, 250. Alright, so my total is 901.22 millimeters squared. So that's the total area that the conductors are going to take up. Alright, so now I got to go to my last table here, hopefully, which is going to be table 9. And I just know from doing this that it's going to be 9G. 9G is going to give me my 40% fill, which is what I determined I could fill that conduit to. So it's done the math for me already. So it's going to be, I need to fill it 901 millimeters squared. So obviously this 810.73 is not going to cut it, which would be a trade size 53. Not big enough. So I got to go to my next highest, which actually fills it to an extensive amount. 1,824.15 millimeters squared, more than enough. That's going to give me a trade size of 78. Alright, so that would be my answer. 78. Now, if you're used to metric like I am, or sorry, imperial like I am, you could go to the codebook again. And it's actually got a conversion chart. So you would want to go to conduit tubing and fitting sizes. There'd be 78 there. And then you would know that that equates to 3 inches. So that would be another correct answer for this particular question. And there you have it.